Welcome to another edition of RCE. Again, this is Brock Palen. You can find us online at rce-cast.com. You can find links to the blogs, to Twitters, and all the usual stuff on there. Once again, I have Jeff Squyres of Cisco Systems and one of the authors of OpenMPI. Jeff, thanks a lot for your time.
Hey, Brock. Nice to talk to you again. And so this is one of those little awkward times, right? We're in post-supercomputing, pre-Christmas. You know, you might get the episode out by the end of the year. It might be early January. But regardless of the strange timing, we have an interesting topic today because this is actually something that I am actively working on. And with our guest today, I actually work with him quite frequently. So I'm going to have to intentionally play dumb to some of these questions to give a little just pretend it's an actual interview.
Okay, so yes, you gave a little bit away there, but our guest today is going to be talking about a library called Libfabric. So, Sean, why don't you take a moment to introduce yourself?
So, hello, Brock, Jeff. My name is Sean Hefty. I currently work with Intel. I've been with Intel about 20-some years. I'm involved with Libfabric, developing network and high-performance interfaces to hardware. I also work with the Linux RDMA kernel. And to focus what we're looking at with Libfabric, you may also hear me call it OFI, Open Fabric Interfaces. This is basically a new set of interfaces that we're trying to develop in the open source to bridge the gap between higher level applications like MPI and PGAS and SHMEM to high performance hardware like InfiniBand, iWarp, and those sort of devices.
So, can you expand on what exactly a fabric normally means to most people in high-performance computing?
So, our use of a fabric is basically a small self-contained network. They meet at clusters as opposed to the internet. So, we're looking at really systems that are tightly coupled. Usually, often may not have routers involved. Usually, it's just going to be switches. If there are routers involved, there'd be a very small number. So we're talking about a network that really exists within a single building, maybe one floor of a building, for systems that are trying to solve one single problem.
Okay, so what is Libfabric then?
So Libfabric is an effort it's a library. It's basically started out as a framework of different sets of interfaces that work together to try to export services of a fabric or of a network up to the applications. So it's not just really this is an interface that you want to have with the network. These are really the services that the network can offer. Stuff like RMA or RDMA capabilities, atomic operations, maybe something like collective operations. So we're looking at trying to define a library that exposes these interfaces, these capabilities up to the apps for them to be able to take advantage of what the hardware can really provide and what the switches can help provide as well.
And so is there really nothing like this in existence already? I mean, what is the use case for creating a new library versus, for example, expanding on an existing library?
So we looked at several libraries. The most common one you see in existence really now is libib verbs. And the verbs library, it works well for InfiniBand devices. It's designed around the InfiniBand hardware and what the InfiniBand hardware is exposing and capable of. What we're trying to do is expand that beyond. This is not just InfiniBand. We want a set of APIs that are fabric agnostic, for example. We don't want to tie it into a specific model of you must make progress this way. You must implement this sort of feature in your hardware. We want to be able to say you implement it in software, implement it in hardware. From our interfaces, we don't care how it's implemented. We don't want to tie into a specific vendor or a specific topology or architecture such as InfiniBand. So I don't know that there's really nothing we've seen that's out there that tries to provide this lower level interface that's an abstraction of what the services are that the fabric is providing.
Now, in some ways, the way you just described that is kind of like the charter of MPI itself, right? It's meant to be a relatively low layer abstraction, gets you into very close performance harmonization with the network hardware itself, right? So you're adding very little software overhead and things like that. You know, you're low level and provide abstracting away what the underlying network actually is. How would you differentiate this from the MPI API?
So this is, I think, a set of interfaces that are MPI is one of our primary consumers, obviously. MPI, SHMEM, and the PGAS. But MPI is one of our major focus areas. So this is providing interfaces so the MPI doesn't have to talk directly to hardware. You don't really want MPI to have to code to every piece of hardware to write to hardware registers, for example. So this is basically an abstraction above writing to the hardware registers. Now, these are the services that the provider's giving up to MPI, so the MPI can really focus on creating optimizing for different types of hardware based on different features, rather than optimizing on this vendor's version 3 of their hardware does something. I want to that vendor's version 4 does something different. Really abstracting that away from MPI so that the vendors, as they change their hardware, can add new features without requiring MPI to change and to update for every feature that the hardware is giving. So it's going to be some protection, I think, from MPI to have to change for every piece of hardware. The hardware vendor themselves deals with providing these services up to the application.
So some network vendors already provide pretty high-level abstractions instead of verbs. Things like specifically MXM, MX, create portals. Why not just use one of those or build on top of one of those?
So in some cases, the interfaces you mentioned are proprietary, right? They're vendor specific. MXM, for example, is Mellanox specific. So you really would be asking other vendors to try to adopt possibly a competing vendor's API as their own. So you may not even have the ability to do that because of copyright or IP restrictions on using those interfaces. In some of the cases, those APIs are abstractions, but they're really abstractions on top of lower level APIs, and that's what we're targeting, is that lower level. For example, MXM is implemented on top, and it's really targeting a specific type of hardware, which is InfiniBand. MX, for example, targeting MeerNet. So again, you have a vendor-specific set of interfaces that was targeting a specific vendor's hardware. Even Intel has the PSM as an interface that targets their hardware and their protocols that they use. So this is, rather than saying we don't want to necessarily pick a single vendor, because for an open source effort here, picking a vendor, you're not going to get pull or push behind it to say, hey, yeah, change your hardware or change your implementation to use this other vendor's interface. So I think there is an issue there, at least from a business sense, of trying to say we can't pick a specific vendor's hardware or interface to move forward. Are there other alternatives that we can use?
Okay, so those interfaces are all proprietary, but obviously you're still going to be running on those networks. So is there going to still be like a vendor-provided lower level thing they give to Libfabric?
There will be. So Libfabric's designed, and we're not tossing the ideas and trying to start over from scratch. We're trying to make sure we leverage all the ideas that these existing interfaces have, the services they have, the capabilities they have, and just try to improve upon it. So within like libIB verbs, for example, you have vendor-specific plugins to verbs to interface that do the implementation. We have the same concept in Libfabric. Each vendor will provide their own implementation to their hardware of these different interfaces.
Okay, so let's take a step back here and say why should HPC customers or even end users, why should they care about Libfabric? You know, if Mellanox has frankly done a brilliant marketing game of getting their brand and Mellanox and